Welcome to the Explainer. Let's just dive straight into a massive pain point for technical leaders everywhere. You want the incredible power of generative AI, right? But how on earth do you keep it from hallucinating wildly and potentially costing your company millions? I mean, we've all seen the horror stories of chatbots going completely rogue. So the real question is, how do you keep it strictly on track so it actually follows your specific hard-coded business rules every single time?
To answer that, today we're breaking down a really practical tutorial by Jobit Verghese. Instead of just theorizing about AI safety, it explores exactly how to build a highly controllable, enterprise-ready AI agent. And we're doing this by combining old-school, rock-solid deterministic data processing with cutting-edge few-shot prompting, all within IBM Watsonx Orchestrate. It's this fascinating blend of the old and the new to solve a very modern problem. Here's our quick roadmap for today. 1. The AI Consistency Challenge. 2. The Sales Intelligence Orchestrator. 3. Building the agent pipeline. And 4. Testing the reliable agent. Let's get right to it.
Starting off with Section 1, the AI Consistency Challenge. Now, notice the stark contrast between these two approaches. On the one hand, we have the old way. Unpredictable AI chatbots relying heavily on zero-shot reasoning. You basically just ask them a question, cross your fingers, and hope they figure out your specific business logic on the fly. And usually, they really struggle. Best case, they give you a generic, unhelpful answer. Worst case, they confidently hallucinate a completely fake refund policy that your support team suddenly has to honor. It's a huge liability. But then we have the new way, structured AI agents. These agents expect deterministic processing up front, and they are rigidly bound by strict organizational guidelines. Because when large organizations introduce AI agents into their workflows, they don't just want creative, chatty responses. They need hard, actionable insights that explicitly respect established business rules without ever going off script. So the absolute secret weapon to achieve this ironclad consistency is few-shot prompting. Now, a lot of people jump straight to the most complex solutions out there, but rather than relying on that zero-shot guessing or blowing hundreds of thousands of dollars and massive GPU resources on heavy model fine-tuning, few-shot prompting gives us a remarkably lightweight alternative. It essentially acts as a binding reasoning contract between your private data and the language model. You're systematically showing the AI, hey, when you see data that looks exactly like this, I want you to format your response exactly like that. It completely removes the guesswork. By feeding the model highly structured examples of inputs paired with your exact desired outputs, you guide its reasoning perfectly. It dramatically reduces error rates and keeps your infrastructure incredibly lean. So how does this actually look in practice? That brings us to Section 2, the Sales Intelligence Orchestrator. Think of traditional deterministic Python code in your standard business guidelines as the physical guardrails on a high-speed highway. It's a pretty well-known and honestly kind of funny fact that large language models, despite their sheer brilliance and ability to write poetry or complex code, are notoriously terrible at basic arithmetic. Seriously, you do not want a generative AI guessing your quarterly revenue attainment or dynamically calculating employee commission payouts. That is a total recipe for disaster. Instead, you write traditional Python code to definitively calculate the math first. Then you provide business context documents to establish the operational rules. Together, the Python logic and those context documents keep the AI's reasoning safely moving in the exact right direction. It's a highly controllable approach. You're using the right tool for the right job, math for the script, and reasoning for the LLM. Consider this synthetic sales dataset our agent is going to process. Notice the strategic choice being made here. We're completely bypassing the AI's mathematical skills. If you look at the columns for revenue attainment and pipeline coverage, we aren't feeding raw sales numbers to the AI and just asking it to figure out those percentages. No way. We're computing these metrics deterministically first, using our Python code. It's only after those hard numbers are completely locked in, verified, and error-free that we pass them over to the large language model. The LLM's only job at that point is to look at those verified numbers and generate the natural language insight. This completely saves us from any potential mathematical hallucinations. All right, moving right along to Section 3, building the agent pipeline. To keep things incredibly modular and maintainable, the developer sets up 3 distinct directories. And this isn't just about being neat and tidy, it is an absolute enterprise best practice for scaling AI. First, the analysis engine folder holds our Python logic and the raw sales CSV data. Second, the business context folder holds our standard text documents detailing performance standards. And third, the orchestrator folder holds a simple YAML file that configures our agent's actual instructions and tool bindings. Now, why should an enterprise developer care about this specific 3-folder setup? Because this separation of concerns means your data engineering team can update the Python math, or your HR team can update the business context documents without ever having to touch or accidentally break the AI agent's core configuration. Everything has a dedicated place, which drastically reduces maintenance headaches down the line. The crucial engine of this whole operation is the 5-step Python pipeline residing in that first folder. It sequentially loads the data, sets up the few-shot examples covering various performance scenarios, computes the math, compiles the prompt, and finally defines the tool. What's truly fascinating here, and honestly a brilliant architectural choice, is the specific role of LangChain. In a lot of AI tutorials you'll see, LangChain runs the whole show as this overarching execution framework. But here, it's used exclusively as a prompt compiler. It's just assembling the data and those few-shot examples into a perfect formatted string. The actual heavy lifting, the model execution, and the safety guardrails are entirely handed off to Watsonx Orchestrate. It's an incredibly efficient way to utilize LangChain's best text formatting features while relying on enterprise-grade infrastructure to actually execute the task. Alongside the code, there are 2 essential knowledge documents uploaded directly to the Watsonx Orchestrate user interface. The first document strictly dictates performance standards, defining exactly how sales metrics should be interpreted by the business. The second document is for escalation guidelines. It maps out the exact required actions based on severity. Like when to simply notify a regional manager versus when you need to escalate an issue all the way to global leadership. The AI agent treats these 2 files as its absolute, unshakable source of truth. It grounds every single piece of reasoning completely in these documents, ensuring that every recommendation it spits out is already pre-approved by corporate policy. Okay, Section 4, Testing the Reliable Agent. Let's see this thing in action. Here is the moment of truth. Imagine a user types this natural language question into the chat UI. Give me a sales performance summary for all regions. It seems like a super simple request. But behind the scenes, the agent is doing something incredibly sophisticated. It breaks down that natural language question, understands the user's intent, and instantly triggers a tool call directly to our Python pipeline to fetch the hard, verified data. The Python pipeline calculates those exact metrics, applies our curated few-shot examples, and compiles a prompt. Then, Watsonx Orchestrate checks the uploaded business documents. And the result? The agent returns an executive-ready insight perfectly aligned with the company's escalation rules. Notice the depth of this response. It doesn't just panic and say, oh no, EMEA is down. It correctly computes the numerical drop, cross-references the business rules, assigns a medium severity, and then recommends the exact protocol dictated by the company guidelines, notifying the regional manager. This is total predictability. This is an AI that you can actually trust to put in front of your executives or your customers because it is mathematically incapable of recommending an action outside of your predefined guidelines. To wrap this all up, this architecture gives your engineering team a massive, almost unfair operational advantage. Let's really look at this comparison one more time. If you rely on heavy retrieval-augmented generation or try building custom fine-tuned models from scratch, you are committing to highly complex infrastructure, massive cloud computing costs, high latency, and constant, grueling maintenance. It's a huge burden. But this lean, few-shot approach combined with deterministic Python, it's highly predictable, incredibly lightweight, and so much easier to iterate. If your business rules change tomorrow, you don't need to retrain a multi-billion parameter model. You literally just update a few examples in your code or swap out a Word document, and the agent's behavior updates instantly. The return on investment for this lean approach is absolutely staggering for enterprise teams. Which leaves us with this final, provocative thought to take away. Now that you know exactly how to build perfectly constrained, highly reliable AI agents that actually respect your business rules, where will you deploy them first? Will it be pipeline risk scoring, automated customer health monitoring, or maybe overhauling your entire internal operations dashboards? When you completely remove the risk of hallucinations, the possibilities for structured, predictable AI are truly endless. Thanks so much for joining me, and I'll see you on the next explainer.